Hello and welcome back to another Algebra 1 video. Today we'll be continuing on with Chapter 4, which covers everything on solving systems of linear equations. If you recall from my previous video, we learned how to solve a system of equations by graphing. We'll be doing the exact same thing today, except this time we'll be learning a method that doesn't involve graphing called substitution. I'll just go ahead and outline the steps of substitution, and then we'll do a few examples to see how it works. So for step 1, we're going to solve one of the equations for one of the variables. So this just means that you're going to get one of the equations and set it either to x or y. Step 2, you're going to substitute the expression from step 1 into the other equation and solve for the other variable. So what this means is if you solved for one of the equations and set it to y, then you would plug in that expression for the y value in the other equation. And then lastly, you're going to substitute the value from step 2 into one of the original equations and solve. You might notice that there's a lot of substituting values in the steps. It might seem a little confusing right now, but let's go ahead and do a few problems to see how it works. Let's solve the system of equations by substitution. We have y equals 2x minus 4 and 7x minus 2y equals 5. Now for our very first step, we want to solve one of the equations for either x or y. So that means one of the equations should be set to either an isolated y or x. Conveniently, equation 1 is actually already solved for y, so we don't have to do anything for step 1. Since y is set to the expression 2x minus 4, you can actually plug in this expression into the y value of the other equation. So this is how it would look like. Our second equation is 7x minus 2y equals 5. And as we said, we're going to plug in 2x minus 4 for our y value. So you would get 7x minus 2 times 2x minus 4 equals 5. Now you can use order of operations to solve this. First, I'm going to use distributive property to eliminate the parentheses. Remember to always look at what sign is in front of the number you're distributing. In this case, it's negative 2. So negative 2 to positive 2x would be negative 4x. And then negative 2 times negative 4 would be positive 8. And if we bring down our remaining terms, we have 7x minus 4x plus 8 equals 5. Now you can combine like terms, and that would be 7x minus 4x in this case. Those two would just simplify to 3x. And then lastly, you can go ahead and solve for x using inverse operations. This looks like a multi-step equation, so I'm going to first undo any subtraction or addition. So subtract 8 from both sides. 5 minus 8 would be negative 3, and now you're left with 3x equals to negative 3. Use inverse operations to solve for x. So it's negative 3 divided by 3 would give you x equals to negative 1. Now you might think that you're already done with solving your system of equations, but remember that the solution for a system is going to be an ordered pair, so x and y. However, as of now, you only have x. So what you want to do is you want to plug in x into one of your original equations so that you can solve for y. It can be any of the two equations that you were given. I'll just go ahead and use y equals 2x minus 4, but again, you can use whichever you'd like. So if we plug in negative 1 for x, you get 2 times negative 1 minus 4. 2 times negative 1 would be negative 2 minus 4, and y would equal to negative 6. So your solution would be negative 1, negative 6. Let's look at another example. We have x plus y equals 13, and x equals to y plus 3. First step is to solve one of the equations, it could be any of them, to either set them to x or y. As we can see here, one of our equations is actually already set to x, so we don't have to do step 1 since it's already been done for us. So x equals to y plus 3. Since our equation is set to x, we can plug in our expression y plus 3 for our x value in our other equation. So this would give you y plus 3 plus y equals 13. And now that you've plugged in your expression, you can go ahead and simplify. I'm going to first combine like terms, so y plus y would just be 2y plus 3 equals 13. And now I'll go ahead and start solving for our y value. This looks something like a multi-step equation, so I'm going to first undo addition by subtraction. So 13 minus 3 would just equal to 10, and now you're left with 2y equals 10. To finally solve for y, you can use inverse operations to undo multiplication by dividing both sides by 2. 2 will cancel and you're left with y equals to 5. Again, remember that systems of equations need an ordered pair for their solution. So you're not quite done yet once you've gotten one of the values, either x or y. You do have to plug it back into one of the original equations to find the other value. So you can either plug in y equals 5 into x plus y equals 13, or you can plug it into x equals y plus 3. I think x equals y plus 3 would be easier since it's already set to x, so I'll go ahead and plug in 5 for y. That would give me x equals to 5 plus 3, and 5 plus 3 would just equal to 8, so your x value would be 8. And finally, you can express your solution in an ordered pair, which is x, y, and that would look like 8, 5. And that's how you solve a system of equations by substitution. Here is another example. We have y equals 3x, and 2x plus 4y equals to 28. First step is to solve one of the equations for a variable, either x or y. Again, in this example, conveniently we have y equals 3x, where 3x is already set to an isolated y, so you can just plug in 3x for your y value in the other equation. So that would look like this. Since y is being multiplied by 4, you would just multiply 4 by 3x, and that would give you 2x plus 4 times 3x equals 28. Now you can simplify. 4 times 3x would equal to 12x, and now you have 2x plus 12x equals to 28. And you can combine like terms, so that would be 2x plus 12x. Those would add to be 14x equals to 28. And lastly, you can divide both sides by 14 to isolate x. So x would equal to 2. Now that you have your x value, you can plug it into one of the original equations to find y. I'll go ahead and plug it into y equals 3x since this is the simpler equation and it's already set for y, so you wouldn't have to do any additional steps to isolate your y value. So that would be y equals to 3 times 2, and 3 times 2 is just 6, so your y value would equal to 6. Again, express your solution as an ordered pair, which is x, y, and your ordered pair would be 2, 6. Here is our next example. We have x plus y equals to 5, and 2x plus 3y equals 11. Now notice this time we don't have any equations that are set to an isolated variable like x or y. So we're going to have to take one of these equations and use inverse operations to set it to an isolated variable. I'm going to go ahead and use x plus y equals 5 since it's the simpler equation between the two, and we wouldn't have to do too many steps to rearrange it. So I'd go ahead and set it to x. You can also set it to y if you'd like, but I'll just go ahead and do x. And to do that, I would just subtract y from both sides. Y would cancel, and now you're left with an equation that is set to x. So you have x equals 5 minus y, and now that we finished step 1, you can plug in this expression that is set to x into your x value in the other equation. So your equation would look like this: 2 times your x value, which is 5 minus y, plus 3y equals to 11. Now we can go ahead and start solving for our y value. First, I'm going to do distributive property to eliminate our parentheses. 2 times 5 would be 10, and 2 times negative y would be minus 2y, so we would have 10 minus 2y plus 3y equals to 11. Now I'm going to combine like terms on the left side. That would be minus 2y plus 3y, so that would leave me with positive y. So we have 10 plus y equals to 11. And now to solve for y, you just need to subtract 10 from both sides using inverse operations. So 11 minus 10 would equal to 1, and there is your y value. Now that we have our y value, we can go ahead and plug it into one of the original equations to solve for x. I'll actually plug it into x equals 5 minus y. Since it technically is still an original equation, it's just rearranged to be equal to x. So that would give you x equals 5 minus 1. And you can go ahead and simplify that to x equals 4. And now you have both your x and y values. You can set these into an ordered pair for your solution. That would be 4, 1. Let's look at example 4. We have 4x plus 3y equals to 26, and 2x minus 3y equals to negative 14. Similar to the last example, we don't have an equation that's automatically set to x or y, so we're going to have to use inverse operations to set one of our equations to either x or y. You can do whichever you'd like. I'll go ahead and use 2x minus 3y equals to negative 14, and I decided to set it to x, but again, it's up to your preference. You can set it to y if you'd like. So to do that, I first added 3y to both sides. That gave me 2x equals 3y minus 14. And then to isolate x, I just divided everything by 2. So 2x divided by 2 would cancel. 3 divided by 2 would just be 3 over 2y. And then negative 14 divided by 2 would simplify to negative 7. So my final equation would be x equals to 3 halves y minus 7. Now that we have an equation set to one of our variables, in this case x, we can plug this expression, 3 halves y minus 7, into our x value of the other equation. So our equation would look like this. We would have 4 times 3 halves y minus 7 plus 3y equals to 26. Now we can start simplifying our equation. First step I'm going to do is to eliminate the parentheses by distributing 4 to this expression inside the parentheses. So that would give you 4 times 3, which is 12 over 2y minus 28. And that would just give you 6y minus 28 plus 3y equals 226. And now you can further combine like terms to simplify your equation. So 6y plus 3y would just simplify to 9y minus 28 equals to 26. And now you can solve for y. This looks like a multi-step equation, so remember to first undo subtraction before multiplication. So I would undo subtraction by adding 28 to both sides. 26 plus 28 would be 54, and now we have 9y equals to 54. To solve for y, just divide both sides by 9, and now you have y equals to 6. Now that you have your y value, you can go ahead and plug it into one of the original equations to find your x value. Again, I'm going to use this rearranged equation that we had in the beginning. Again, it's still an original equation, it's just rearranged to a certain variable. And since it's already set to x, we just have to plug in our y value, simplify, and we have our x value. So taking x equals 3/2 y minus 7, I'm going to plug in 6 for y. That would give you 3/2 times 6 minus 7. 3 times 6 would just equal to 18. And then 2 times 1 would just be 2. So 3/2 times 6 would just equal to 9. And now you have x equals to 9 minus 7. 9 minus 7 would just simplify to 2, so your x value would equal to 2. Again, express this as an ordered pair, so your final answer would be 2, 6. Here is a word problem for us to try. So you buy a total of 50 turkey burgers and veggie burgers for $90. You pay $2 per turkey burger and $1.50 per veggie burger. Write and solve a system of linear equations to find the number t of turkey burgers and number v of veggie burgers you buy. I already went ahead and underlined any important information. So I underlined that we bought a total of 50 burgers and that it amounted to $90. We know that the price per turkey burger is $2 and the price for veggie burger would be $1.50. The variables we're using is t for turkey and v for veggie burgers. So we're going to solve a system of linear equations. Now, given this information, they want us to make a system of linear equations so that we can solve it and find the number of turkey and veggie burgers that we bought. So first, we know that we bought a total of 50 turkey burgers. However, we don't know how many turkey burgers we bought and how many veggie burgers we bought. So that would be the unknown variables t and v. Our first equation could just be about how many burgers we bought. So we could do number of turkey burgers is t plus v, which is veggie burgers, equals the total number of burgers that we bought, which is 50. The second one I did was about the price. So looking at this information, we have one about the number of burgers we bought, and then the other information we were given is about the price that we paid and how much each burger cost. So we know that the total was $90, so I'm going to set the other equation to 90. And we also know that each turkey burger equals to $2. So that would be 2 times every turkey burger, or t, plus $1.50 per veggie burger. So that would be $1.50 times every veggie burger, which would be represented by the variable v. Now you have a system of equations that you can solve using substitution. So the first step we want to take is to have one equation set to a variable, so in this case either t or v. I'm actually going to set t plus v equals to 50 to t, since it's much easier to rearrange this since you just have to subtract v from both sides to set it to t. You can also set this equation to v if you'd like, or you can set 2t plus 1.5v equals 90 to either t or v, but again, just try to simplify the process and identify which one would be easier to rearrange. So my rearranged equation would be t equals to 50 minus v. So I'm going to plug in this expression 50 minus v, which is our t value in this case, and plug it into our other equation as the t value. So we would have 2 times 50 minus v plus 1.5v equals to 90. Now you can simplify your equation. First, I'm going to distribute 2 into the expression inside the parentheses to eliminate the parentheses. So 2 times 50 would be 100, and then minus 2v, since 2 times v would just be 2v, plus 1.5v equals 90. Now further simplify your equation by combining like terms. So negative 2v plus 1.5v would just equal to negative 0.5v. And then once you have that, you can actually subtract 100 from both sides so that you would have your variable isolated on one side. So 90 minus 100 would just equal to negative 10. So you would have negative 0.5v equals to negative 10. And lastly, divide both sides by negative 0.5 so that you can isolate v. So negative 10 divided by negative 0.5 would equal to positive 20. So the number of veggie burgers that we bought was 20. However, we know that we need to find both the number of turkey and veggie burgers. So go ahead and substitute v equals 20 into your original equation to find t. So I'll go ahead and substitute v into t equals 50 minus v so that we can find our t value. 50 minus 20 would equal to 30, so our t value equals to 30. Lastly, we can summarize our solution that we buy 20 veggie burgers and 30 turkey burgers. If ever you want to check your solution, you can go ahead and plug these values into the original equation. So again, our v value would equal to 20 and our t value equals to 30. So you can plug that into each of your original equations. T equals to 30 plus v, which equals to 20. And that does indeed equal to 50, so that checks out. Do the exact same for the other equation if you'd like. 2 times t, which is 30, plus 1.5 times v, which is 20, and it should equal to 90. So 2 times 30 is 60, and then 1.5 times 20 would equal to 30. So 60 plus 30 does indeed equal to 90, so that checks out. You can actually do this for any system of equations. Just plug in the values that you got into the original equations and make sure that they check out. Here is one last problem for us to try. It's exactly the same as the previous one, except now we just have a different situation and different numbers to work with. So a juice stand sells lemonade for $2 per cup and orange juice for $3 per cup. The juice stand sells a total of 100 cups of juice for $240. Write and solve a system of linear equations to find the number of cups of lemonade represented by the variable L and the number of cups of orange juice, which is represented by the variable J, sold. So the first thing I like to do is underline all the important information. And then I like to identify what my two equations are going to be set to. So in that case, it would be the total of cups of juice that we sold and the total amount of money that the juice stand made from selling all that juice. So the total would be 100 cups and the total amount would be $240. We don't know the number of cups of lemonade or orange juice that we sold, so we would just leave L plus J equals to a total of 100 cups of juice. But we do know that each cup of lemonade is $2 and each cup of orange juice is $3. So you can set one of your equations to the total of $240 and you would have 2 times L, which represents lemonade, plus 3 times J, which represents orange juice. Now that you have your system of equations set, you can actually now solve this using substitution and find your L and J values. First thing you want to do though is solve one of the equations for a variable. Again, I'll use L plus J equals 100 since you would just have to subtract one of the variables to isolate either one. So I went ahead and solved for L, but you can solve for J if you'd like, and I just did that by subtracting J from both sides. That gives you L equals to 100 minus J, and now that you have one of your equations solved for a variable, you can plug it into your other equation. So in this case, I would plug in 100 minus J for L. That would be 2 times 100 minus J plus 3J equals to 240. Now eliminate your parentheses first by distributing 2. And that would give you 200 minus 2J plus 3J equals to 240. You can now combine like terms to further simplify your equation. So negative 2J plus 3J would just give you positive J. So that would give you 200 plus J equals to 240. And now you can finally solve for J by subtracting 200 from both sides. So 240 minus 200 would give you J equals to 40. Now that you solved for J, you can go ahead and plug in J into one of the original equations so that you can find the number of cups of lemonade that you sold. So again, I'm going to use L equals 100 minus J since this is an original equation. Just rearrange to L, and that would give you L equals to 100 minus 40, and that would simplify to L equals 60. So you sold 40 cups of orange juice and 60 cups of lemonade. And again, if you'd like, you can plug in your L and J values into the original equations to check if your solutions were correct, and they should check out. That is it for today's video. Thank you so much for watching. As always, all information regarding tutoring, additional practice, and lesson requests will be linked down below in the description box. If you ever have any general questions about the lessons, please feel free to contact me at this email, and I hope to see you in the next video.